A tornado is a violently rotating storm of a small diameter. It is the most violent weather phenomenon with the strongest winds in nature. A tornado is produced in a very severe thunderstorm. It forms a rotating column of air called a vortex that appears as a funnel cloud extending from the base of a cumulonimbus cloud to the ground. Other names for tornado are twister or cyclone. In very extreme cases, we can see wind speeds in excess of 300 miles per hour, which are caused by a tremendous pressure gradient. The pressure inside the tornado can be 10% or approximately 100 millibar lower than on the outside. Air rushes into the center of the vortex and is spiraled upward. Tornadoes develop in association with severe thunderstorms, which could be caused by cold fronts, squall lines, tropical cyclones, or supercells. Luckily, less than 1% of the thunderstorms produce tornadoes. Tornadoes are typically preceded by so-called mesocyclones, which are vertical cylinders of rotating air. Approximately half of the mesocyclones produce tornadoes. So how do such mesocyclones develop? For that to happen, we need strong wind shear, which is the difference between winds at lower and at upper levels. It could be that we have very strong winds aloft that produce a rolling motion around a horizontal axis. This rolling motion around a horizontal axis could also be produced by a change in wind direction between lower and upper air. If this horizontally rotating column of air gets into the region of an updraft within a thunderstorm, then it is tilted upward. This results in the column of air rotating around a vertical axis. Eventually, the vortex develops from wide and short to long and narrow. This change causes the increase of wind speeds due to the conservation of angular momentum. The animation illustrates again the wind shear, the rotating column of air getting into the region of the updraft, tilting vertically, and resulting in the mesocyclone. Notice the overshooting top at the top of the cumulonimbus cloud. This narrowing column stretches downward until a portion protrudes below the cloud base and forms a very dark wall cloud. And finally, a slender, rapidly spinning vortex emerges from the base, which is called the funnel cloud. If the funnel makes contact with the surface, it is called a tornado. This is a very general description. In fact, it is not yet fully understood how a tornado actually develops. Some research actually points towards a phenomenon that is called the rear flank downdraft that promotes the development of tornadoes from supercell thunderstorms. Here is the idea. Dry air at the mid and upper level is pushed towards the backside of the rotating updraft. It forces the rotation to concentrate and lower to the ground. This sinking air behind the updraft is called the rear flank downdraft. Given that it is relatively dry air that is sinking, it produces a visible, clear slot that is wrapping around the wall cloud. This dry slot, called the fold, produces a very unique radar image that is characterized by the hook. Another attempt to explain this narrowing and stretching column of air is the so-called dynamic pipe effect model. It assumes that rotation first increases aloft. Weakly rotating air is sucked up into the pipe's lower end. Air spins faster and eventually becomes part of the pipe. New sections on the rotating pipe form at lower and lower altitudes, and the young tornado will build downward. In comparison to other parts of the world, the United States experiences a disproportionately large amount of tornadoes per year. The reason for that is that, in contrast to other parts of the world, the United States do not have a natural mountain barrier that would be an obstacle to cold air masses from the north colliding with warm air masses from the south. Theoretically, tornadoes can develop anywhere in the United States when the conditions are right. In reality, we find regions that are far more likely to be impacted by tornadoes. The most likely meeting point of contrasting air masses is in the central United States. Large, destructive tornadoes are therefore most common in the Central Plains. The Tornado Alley is located in the Central Plains in states like Texas, Oklahoma, Kansas, and Nebraska. Extreme tornadoes are also concentrated in the southern United States from Arkansas to Alabama. On average, 1,200 tornadoes occur in the United States per year. The highest frequency of tornadoes in the United States is in the springtime, from March to June. Springtime is characterized by greatly contrasting conditions of air masses associated with these mid-latitude cyclones. Continental polar air from Canada is still very cold and dry, and maritime tropical air masses from the Gulf of Mexico are warm, humid, and unstable. The movement of the jet stream and the progression of the maritime tropical air masses cause tornadoes to occur later in the year in the north. The state with the highest number of tornadoes is Texas. The states with the highest number of tornadoes per unit areas are Oklahoma and Florida. The destruction potential of tornadoes is classified by the Enhanced Fujita scale. The Enhanced Fujita scale is a set of wind estimates based on damage. It ranges from F0 to F5. The expected damage of an F0 tornado is relatively light. We might see broken branches and damaged signs. The F5 tornado, with gusts over 200 miles per hour, is associated with incredible damage. Strong frame houses carried away considerable distances, automobile-sized missiles, steel-reinforced concrete structures are badly damaged. Weaker tornadoes are the most common, but the most damage is caused by the violent tornadoes. The damage is mainly caused by violent winds and flying debris. Tornado forecasts are done by the Storm Prediction Center in Norman, Oklahoma. Tornado watches alert people of possible tornadoes in specified areas. Tornado warnings are issued when a tornado was seen or detected by weather radar or observers. Great improvements in tornado forecasting have been accomplished through the establishment of the Doppler radar network. While conventional radar can only indicate rainfall intensity and does not give any information about circulation patterns other than that hook echo signal in the supercell, the Doppler radar can detect motion directly. Establishing and using the Doppler radar network has increased tornado warnings from less than 5 minutes to now approximately 11 minutes.